Hello everyone and welcome to another Leetcode video. Today we're looking at the problem find power of k-size subarrays 1 and 2 from Biweekly Contest 137. Before we continue, I just want to ask everyone to please like and subscribe if you're enjoying the content. All your support really helps the channel and helps me continue making videos like this. So the question reads that we are given an array of integers nums of length n and a positive integer k. So the power of an array is defined as its maximum element if all of the elements are consecutive and sorted in ascending order, or -1 otherwise. So we're given this integer k, and we want to find the power of all the subarrays in nums that are of size k. So we want to return an integer where the results are the power of each subarray of size k. You can see here we have the example 1, 2, 3, 4, 3, 2, 5, and k equals 3. So our answer is 3, 4, -1, -1, -1. And why is this? So we start at index 0, and we want to get a subarray of size 3. So we go 1, 2, 3. We see that this is consecutive and in ascending order, and the max element is 3. So we put 3. Likewise, we start at index 1, 2, 3, 4. Same thing, sorted and in ascending order, so we put 4. So then we get to index 2. We see that we have 3, 4, 3. So this is kind of consecutive. We have 3 consecutive to 4, consecutive to 3, but it's not in ascending order. We want it to be like 1, 2, 3, strictly increasing. So for that reason, we put -1 in that spot. And you'll see that the output size array is different than the input size. And that's because we're only going to index 1, 2, 3, 4, 5, right? We're only going up to here because we have to extend this by 3, right? We can't start at 2 because we have a k of 3, and going to 3 forward would take us out of bounds. So here we have 5 subarrays, as you could see, but only 2 of them are consecutive. The rest we fill with -1. So let's hop over to an example and see how we could solve this. So for question 1, the constraints are pretty low, so we could actually just use a straight up brute force algorithm to solve this. I'm not really going to go into the code for that, but just to conceptually understand how that would work. So we want to, for each element, we want to find a subarray of size k starting from there. So if we start at 1, we want to go 1, 2, 3, right? This is a size 3 subarray. And basically, we're going to see, is this consecutive? And we're going to find the max. So literally all we're doing is we're starting at 1, and then we're going to iterate until we're up to size k. We have 1, 2, 3, get the max, which is 3, and put it in our array. Then we'll go forward, right, and do the same thing. So we start at 2, we go to 1, 2, 3, we put 4, we go forward again, start here, 3, 4, 3, we see it's not consecutive, so we don't get the max. So you'll see basically what we're doing here is we just, for each index, if we can go forward and get a size of k, we're just going to do that and just do that iteration. So that overall would be O of n times k. Right? And this is fine for question 1. It works, it's brute force, but for question 2, our constraints are a bit higher, and we can't actually use this method to solve it. So how would we do it in that case? So let's actually think about where we can optimize things. What's the redundant work that we're doing? Well, we see that for each index, right? Say we start at 1, we're going 1, 2, 3. And then we go to 2, we're going to 2, 3. Remember, in our previous iteration from 1, 2, 3, we already checked this interval, right? We saw that that was consecutive already. So you'll see that since we're iterating for each index up to k times, we're actually going over the same elements a lot of repeated times, right? And we don't want to do that. We want to keep our iterations as few as possible. So instead of having to iterate every time, what if we did some kind of pre-computation so that we can know, like at this point, have we seen previous consecutive elements and how many have we seen, right? So what would that look like? So what if we had an array where at each point, we kept track of how many previous consecutive elements that we've seen. So here, we're just going to start with 1. And why do we start with 1? Well, technically, if we have just an array of size 1, right? This is technically consecutive with itself. This is a subarray that is basically one consecutive element. So that counts. So if we had just one element, we start with 1. So now we're going to go to 2. And what do we do here? Well, we look at our previous element and see, is 2 consecutive to 1? Well, yes, it is. So what do we do in this case? Well, we could say whatever length our consecutive sequence ends here, right? So say we have a sequence of length 1 ending here. Well, we know we can add this to whatever ends there and increase it by a length of 1. So essentially, we're taking our previous value because we have a consecutive subsequence ending there. We know we can add our current value, so we're just going to add 1 to that. So we add 2. Similar case with 3. We see we can continue this consecutive subsequence starting here. So we just say, all right, well, let's take whatever length is that ends here, and we're going to add 1, right? So we get to here, same thing with 4. And then here is where our case changes with this 3. So we say 3 is not consecutive to 4. So essentially what we're doing is saying, with this 4, we can't continue that consecutive sequence, right? So we have to basically start a new one. So we're going to start over and say, at this point, we only have a sequence of length 1 that's consecutive, right? Then we go here, same thing here, we get 1, 1. Okay, so we've generated this array. What does this actually tell us? What can we do with this? So let's just look at an example here, right? So say we're looking at this example here and we have 4. What does this 4 tell us? Well, this tells us that at this point, right, we have seen 4 consecutive elements. Okay, so we know that our k is 3. So if we see we have 4 consecutive elements, we know that this ending point here is a valid candidate because it's greater than our 3, right? We need 3 consecutive elements, but here we have 4, right? So this is a case where we want to find the max. So how do we find our maximum value? Well, I guess we could go over, we know that this is a length k, so we could go back to this point and iterate through all of these. But remember, these are consecutive and in sorted ascending order. And I think this is a good fact to remember. It's kind of a hint given in the description that if it's sorted in ascending order, well, then this value here, right, in the nums array, this has to be the greatest one. So we don't actually have to go over the entire subarray that we're considering to find the max. We know that it's just whatever we're looking at right now, right? So we say, okay, well, our maximum value is just here. So at this point, we could just take this answer and put that into our array. So likewise, if we come here, right, we see that there's only 1 consecutive element at this point. So we know that this does not meet our k criteria. So at this point, we would just put -1 into our array. So essentially what we're going to do is say, as long as this value we've calculated is greater than or equal to our k value, then we should take that value and put it into our array. And we're doing this because we see that we have enough consecutive values to meet our k criteria, and we know that this value has to be the maximum in that subarray because that subarray has to be in sorted and ascending order. So really what we're doing is just pre-computing one time the number of consecutive elements and using that to help us. So what's the time complexity look like here? So we're going through the array one time, right, to actually get these values, and then going through again just to get our actual result. So overall, we have O of 2n, but this simplifies down to just n. So we've changed this from an O of n times k operation to just O of n, which is sufficient for our use case for question 2. So let's hop over to the code and see exactly how this works. So the first thing we do is we set up our result array as well as our pre-computation array. And we're just starting with 1 in our array. And this represents that our first element in nums, we know that it has a consecutive length of 1, right? We know that we have 1 consecutive element to start our nums array. So we're going to start with that value. Then for every index from 1 to the end of the nums array, what we're going to do is say, if that current value equals our previous value plus 1, then we know that we can continue that consecutive sequence, right? So what we're going to do is into our prefix array, we're going to append that previous value we had there plus 1, which represents us extending that sequence by 1. Otherwise, we know that we can't continue that consecutive sequence, so we're just going to put a 1 in there to represent that we're starting a new sequence. So this is where we actually do the pre-computation. Then this is where we're going to generate our result. So what we're going to do is we're going to iterate through the range k minus 1 to the end of the array. And we do k minus 1 because, for example, if we have our k as 3, we can't start at 0, right? Because we'd have to basically look back past 0 to 0, -1, -2. So we want to start at k minus 1 because we want to think about the ending points of these arrays, right? And we know that the first ending point that we have in the array that we want to consider is k minus 1. So we're going to iterate through all those indexes, and if at any point our computed value is greater than or equal to k, we're just going to take that number in the array and put it into our result because we know that is the maximum. Otherwise, we're just going to append -1 because we know that the array is not consecutive. So at the end, we just return our result. So let's submit this and make sure that it works. And it does work. So hopefully this was helpful. If you like the content, please like and subscribe. It really helps out the channel. And thank you for watching.